Welcome back to my channel LinkedIn Pharma. Today we have discussed about Wastewater Story, Chapter 13, Class 7, Subject Science. Before starting, please like, share and subscribe to this video. Let's start. Introduction to Wastewater. Wastewater refers to any water that has been used and discarded from various sources, such as domestic, industrial, or agricultural activities. It contains a mix of contaminants, pollutants, and organic matter that can pose significant environmental and health risks if not properly treated and managed. Addressing the challenges of wastewater is crucial to ensure water quality, protect ecosystems, and sustain human well-being. Water, our lifeline. Water, often referred to as our lifeline, is an essential and precious resource that sustains all forms of life on Earth. It plays a fundamental role in supporting ecosystems, agriculture, and human existence. From quenching our thirst to nurturing crops and regulating climate, water's significance is undeniable. However, increasing demands, pollution, and climate change pose significant threats to this finite resource. Preserving and conserving water is not only vital for our survival but also for the well-being of future generations. Embracing responsible water management practices is crucial to ensure a sustainable and thriving planet for all. Clean water is a fundamental necessity for all living beings, and its scarcity affects billions worldwide. World Water Day, observed on March 22 annually, raises awareness about water-related issues and advocates for the sustainable management of this precious resource. Access to clean water is vital for human health, agriculture, and economic development, and it is crucial to ensure water for life, for all. Cleaning of water involves the removal of impurities and pollutants to make it safe for consumption and other uses. Various water treatment methods, including filtration, disinfection, and chemical processes, are employed to purify water and make it fit for drinking and other purposes. Sewage treatment is an essential process that treats and purifies wastewater before releasing it back into the environment. Through sewage treatment, harmful contaminants are removed, preventing water pollution and safeguarding ecosystems. In summary, maintaining clean water sources, promoting awareness through World Water Day, implementing effective water treatment practices, and investing in sewage treatment are crucial steps in preserving this life-sustaining resource for current and future generations. What is sewage? Sewage is a term used to describe the wastewater generated from various human activities, including domestic, industrial, and commercial sources. It typically includes water from toilets, sinks, showers, washing machines, and other sources that carry various organic and inorganic substances. Sewage contains a mixture of human waste, food scraps, soaps, detergents, chemicals, and other pollutants. When left untreated or improperly managed, sewage poses significant health and environmental risks. It can contaminate water bodies, spread diseases, and harm aquatic life. Proper sewage treatment is essential to remove harmful contaminants and pollutants before discharging the treated water back into the environment or recycling it for safe use. Effective sewage treatment plays a crucial role in maintaining public health, preserving water quality, and safeguarding ecosystems. Sewage is the used water and waste materials that are discarded from homes, businesses, industries, and other human-related activities. 1. Domestic sewage. The majority of sewage comes from domestic sources, such as toilets, bathrooms, kitchen sinks, and laundry facilities in residential areas. 2. Industrial sewage. Industrial activities also contribute to sewage with discharges containing chemicals, heavy metals, and other pollutants. Components of sewage. The composition of sewage is diverse and can include the following. A. Wastewater. Water used for various purposes, such as bathing, washing, and flushing, which may contain soaps and detergents. B. Human waste. Feces and urine from toilets, which contain organic matter and pathogens. C. Food waste. Leftover food particles and kitchen waste, contributing to the organic content. D. Oil and grease. Discharges from kitchens and industries that contain fats, oils, and greases. A. Chemicals. From industrial processes, cleaning agents, and other sources. F. Heavy metals. Industrial wastewater may contain heavy metals like lead, mercury, and cadmium. G. Microorganisms, bacteria, viruses, and other microorganisms present in human waste. H. Nutrients. Nitrogen and phosphorus compounds from detergents and organic matter. Sewage is a complex mixture containing suspended solids, organic and inorganic impurities, nutrients, saprophytes and disease-causing bacteria and other microbes, These include the following: organic impurities, human feces, animal waste, oil, urea, urine, pesticide, herbicides, fruit and vegetable waste, etc. Inorganic impurities, nitrates, phosphates, metals. Nutrients, phosphorus and nitrogen. Bacteria, such as Vibrio cholera which causes cholera and Salmonella paratyphi which causes typhoid. Other microbes, such as protozoans which cause dysentery. Pollutants and health risks. Untreated sewage poses significant health risks and can contaminate water bodies, leading to the spread of waterborne diseases and ecological damage. Sewage treatment. To mitigate the environmental and health impacts, sewage undergoes treatment before discharge. The treatment process involves several stages, including primary, secondary, and tertiary treatment, to remove solids, organic matter, and harmful substances. Wastewater reuse. In some cases, treated sewage can be reused for non-potable purposes like irrigation, industrial processes, and groundwater recharge, reducing freshwater demand. Understanding sewage and its composition is essential for implementing effective treatment strategies to safeguard public health and protect the environment from pollution. Proper sewage management is crucial for sustainable water resources and a healthier ecosystem. Water freshens up, an eventful journey. Sewers. Sewers are underground channels or pipes designed to collect and transport sewage, stormwater, and sometimes surface runoff away from residential, commercial, and industrial areas. These systems play a crucial role in maintaining public health and environmental cleanliness by preventing the direct discharge of wastewater into natural water bodies and promoting proper sewage disposal. Sewerage. Sewerage refers to the overall infrastructure and network of sewers that facilitate the collection, transportation, and treatment of wastewater and stormwater. It includes the interconnected pipes, manholes, pumping stations, and treatment facilities used to manage and process sewage before releasing it back into the environment. Key points. Sewers are the physical conduits or pipelines that carry sewage and stormwater from buildings and streets to the treatment facilities. Sewerage is the complete system of sewers, which encompasses the entire network, including pipes, structures, and treatment plants. Modern sewerage systems are essential for public health, preventing waterborne diseases, and protecting water bodies from pollution. These systems help maintain hygiene and cleanliness in urban and suburban areas, reducing health risks associated with improper waste disposal. Sewerage systems are carefully planned and engineered to ensure efficient wastewater management and sustainable water resources for communities. The treatment of sewage within the sewerage system is crucial to remove contaminants and pollutants before discharging the treated water back into the environment or reusing it for non-potable purposes. Treatment of polluted water. Treating polluted water is a critical process that involves removing contaminants and pollutants to make the water safe for various uses and to protect the environment. The specific treatment methods used depend on the type and level of pollution present in the water. Here are some common techniques for treating polluted water. Physical treatment. Physical treatment methods involve the removal of solid particles and larger debris from the water. These methods include screening, passing the water through screens to remove large objects and debris. Sedimentation, allowing the water to sit undisturbed to let heavier particles settle to the bottom. Filtration, passing the water through porous materials to trap suspended solids. Chemical treatment. Chemical treatment involves the use of chemicals to facilitate the removal of pollutants. Common chemical treatment methods include coagulation and flocculation, adding chemicals that cause impurities to clump together, making them easier to remove. Chemical precipitation, adding chemicals to form insoluble compounds that can be separated from the water. Biological treatment. Biological treatment utilizes microorganisms to break down organic pollutants present in the water. Common biological treatment methods include aerobic treatment, providing oxygen to microorganisms to break down organic matter into carbon dioxide and water. Anaerobic treatment, treating the water in the absence of oxygen, where microorganisms break down organic matter into methane and carbon dioxide. Advanced treatment. For more complex and challenging pollutants, advanced treatment methods may be necessary. These methods include activated carbon adsorption, using activated carbon to adsorb organic compounds and certain chemicals. Membrane filtration, employing semi-permeable membranes to separate contaminants from the water. Oxidation, using powerful oxidizing agents to break down persistent pollutants. Disinfection. Disinfection is a crucial final step to kill or inactivate harmful microorganisms, such as bacteria and viruses. Common disinfection methods include chlorination, adding chlorine to the water to disinfect it. UV disinfection, exposing the water to ultraviolet UV light to kill microorganisms. Reuse or discharge. After treatment, the water is either reused for non-potable purposes like irrigation or discharged into water bodies, depending on its quality and intended use. Before discharge or reuse, the treated water must meet specific regulatory standards to ensure it does not harm the environment or public health. Overall, treating polluted water is a multi-step process that combines various physical, chemical, and biological methods to ensure safe and sustainable water resources. It plays a crucial role in mitigating the impact of pollution on the environment and human well-being. Wastewater Treatment Plant (WWTP). A wastewater treatment plant (WWTP) is a facility designed to treat and process wastewater from various sources, including domestic, industrial, and commercial activities. The primary goal of a wastewater treatment plant is to remove pollutants and contaminants from the water before it is safely discharged into the environment or reused for non-potable purposes. The process involves several stages to remove contaminants and pollutants from the wastewater effectively. Here is an overview of the typical wastewater treatment process. Preliminary treatment. Screens. Large debris, such as sticks, plastics, and other solid materials, are removed by bar screens or mechanical screens. Grit chamber. Sand, gravel, and other heavy particles settle out in a grit chamber, which is then removed for proper disposal. Primary treatment. Sedimentation. The wastewater enters a primary settling tank where large suspended solids and organic matter settle to the bottom as sludge. Sludge removal. The accumulated sludge is removed and sent for further treatment or disposal. Secondary treatment. Biological treatment. Aeration. In the secondary treatment, microorganisms are introduced to break down the remaining organic matter and pollutants. Oxygen is supplied through aeration to support the growth of these microorganisms. Aeration tank. The wastewater is mixed with the activated sludge, microorganisms, in an aeration tank. Clarifier. After the biological reaction, the mixture goes to a clarifier, where the remaining solids settle, and the treated water rises to the top. Tertiary treatment, optional. Some wastewater treatment plants include additional processes to further polish the treated water for specific purposes like reuse or to meet strict discharge standards. Filtration. The water may pass through sand filters or other media to remove any remaining particles. Disinfection. Chemicals like chlorine, ultraviolet UV light, or ozone may be used to disinfect the water and eliminate harmful pathogens. Sludge treatment and disposal. The sludge generated during the treatment process undergoes further treatment, which may include anaerobic digestion, dewatering, and drying. Depending on the quality of the treated water and local regulations, the treated water may be discharged into nearby water bodies or reused for non-potable purposes like irrigation or industrial processes. The entire wastewater treatment process is carefully controlled and monitored to ensure effective removal of pollutants and protection of the environment and public health. Different wastewater treatment plants may incorporate variations in the processes based on the specific needs and the quality of the influent wastewater. Becoming an active citizen. Becoming an active citizen involves taking proactive steps to contribute positively to the management and conservation of water resources. Raise awareness. Educate yourself and others about the importance of wastewater management and its impact on the environment and public health. Share this knowledge with your family, friends, and community through discussions, social media, or organizing awareness events. Reduce water usage. Conserve water in your daily activities by fixing leaks, using water-saving appliances, and being mindful of water consumption. Reducing water usage helps lessen the burden on wastewater treatment plants and ensures water resources are used efficiently. Proper waste disposal. Dispose of household waste, chemicals, and medications responsibly, following local regulations. Improper disposal can lead to water pollution and harm aquatic life. Support wastewater treatment initiatives. Advocate for and support the improvement of wastewater treatment infrastructure in your community. Encourage local authorities and policymakers to invest in modern and efficient treatment technologies. Participate in cleanup events. Participate in community cleanup events along rivers, lakes, and coastlines to prevent litter and pollutants from entering water bodies. Cleanups help maintain the health of aquatic ecosystems and protect water quality. Report polluters. If you witness illegal dumping or pollutants being discharged into water bodies, report it to the appropriate authorities. Your action can prevent further damage to the environment and hold polluters accountable. Promote water reuse. Support and participate in initiatives that promote water reuse. Recycling treated wastewater for non-potable purposes like irrigation and industrial processes helps conserve freshwater resources. Get involved in community programs. Join local environmental organizations or community groups working on water-related issues. Actively participating in these groups allows you to contribute your ideas and efforts towards sustainable wastewater management. Engage with local authorities. Engage with local government officials and policymakers to advocate for better wastewater management policies and practices. Participate in public hearings and meetings related to water resources to voice your concerns and suggestions. Lead by example. Be a role model for responsible water use and pollution prevention. Your actions can inspire others in your community to adopt environmentally friendly practices. Better housekeeping practices. Better housekeeping practices are essential for maintaining a clean, organized, and safe living environment. These practices not only contribute to a more pleasant living space but also promote health and well-being. Here are some better housekeeping practices to consider. Regular cleaning schedule. Establish a regular cleaning routine to keep your home tidy and organized. Create a weekly or monthly schedule that includes tasks such as dusting, vacuuming, mopping, and cleaning bathrooms and kitchens. Decluttering. Regularly declutter your living spaces to remove items that you no longer need or use. Donate or recycle items that are in good condition and dispose of items that are no longer usable. Organized storage. Use storage solutions like shelves, cabinets, and containers to keep belongings organized and easily accessible. Label containers to make it easier to find items when needed. Wipe surfaces daily. Wipe down countertops, tables, and other surfaces daily to remove dust, dirt, and spills. This practice helps maintain cleanliness and prevents the buildup of grime. Laundry management. Establish a laundry routine to stay on top of clothes and linens. Sort laundry by color and fabric type to prevent color bleeding and ensure proper washing and drying. Clean as you go. Adopt a clean as you go approach, especially in the kitchen. Clean dishes and countertops while cooking to minimize post-meal cleanup. Bathroom maintenance. Regularly clean and disinfect bathroom fixtures, tiles, and surfaces to prevent the growth of mold and bacteria. Vacuum and dust. Use a vacuum cleaner with a HEPA filter to remove dust and allergens from carpets and floors. Dust surfaces, including shelves and electronics, regularly to reduce allergens and improve indoor air quality. Green cleaning. consider using eco-friendly cleaning products to reduce the impact on the environment and avoid harsh chemicals in your living spaces. Pet care. If you have pets, establish a regular grooming and cleaning routine to minimize shedding and pet-related odors. Maintenance checks. Regularly inspect and maintain household appliances, plumbing, and HVAC systems to prevent potential issues and prolong their lifespan. Fire safety. Ensure you have functioning smoke detectors and fire extinguishers. Regularly check and replace batteries in smoke detectors. Outdoor cleanliness. Keep the exterior of your home tidy by regularly cleaning driveways, walkways, and outdoor furniture. Involve family members. Encourage all family members to participate in housekeeping tasks and share responsibilities, making it a collective effort. By implementing these better housekeeping practices, you can create a more pleasant and healthy living environment for yourself and your family. Consistency and teamwork will ensure that your home remains clean, organized, and enjoyable to live in. Swachh Bharat. Swachh Bharat, meaning Clean India, is a nationwide cleanliness and sanitation campaign launched by the Government of India. Launched on October 2, 2014, by Prime Minister Narendra Modi, the initiative aims to promote and achieve a clean and hygienic India by improving waste management, building toilets, and fostering a culture of cleanliness among its citizens. Swachh Bharat Abhiyan envisions a healthier and more sustainable environment for all, emphasizing the importance of cleanliness and responsible waste disposal practices throughout the country. Vermi-processing toilet. A vermi-processing toilet, also known as a composting toilet or a bio-toilet, is an eco-friendly sanitation system that utilizes earthworms and microorganisms to treat human waste and convert it into nutrient-rich compost. How it works. Human waste collection. In a vermi-processing toilet, human waste, feces and urine, is collected in a specially designed chamber. Vermi-composting. Inside the chamber, earthworms and beneficial microorganisms are introduced. These organisms feed on the waste, breaking it down into organic matter through a process called vermicomposting. Decomposition and transformation. During the vermicomposting process, the organic matter is decomposed and transformed into nutrient-rich humus, which is a dark, crumbly material similar to compost. Reduction of volume. The vermi-processing toilet system reduces the volume of human waste significantly through composting, which results in a much smaller quantity of residual material. Benefits of vermi-processing toilets. Environmentally friendly. Vermi-processing toilets help reduce water usage and minimize pollution as they do not require flushing with large amounts of water like traditional flush toilets. Nutrient recycling. The compost produced from the vermi-processing toilet can be used as a valuable resource to enrich soil and support plant growth in gardens or agricultural fields. Suitable for remote areas, these toilets are especially beneficial in areas with limited access to water and sewage infrastructure. Odor-free. Properly managed vermi-processing toilets do not produce foul odors, making them more pleasant to use. Pathogen reduction. The composting process helps in reducing harmful pathogens in the waste, making it safer for handling and disposal. Cost-effective. Vermi-processing toilets can be a cost-effective sanitation solution, particularly in areas where building conventional sewage systems may be impractical or expensive. Although vermi-processing toilets are eco-friendly and can be effective in specific settings, their successful operation requires proper management, regular maintenance, and adherence to hygiene practices to ensure safe and hygienic waste processing. Sanitation and disease. Sanitation plays a crucial role in preventing the spread of diseases and maintaining public health. The relationship between sanitation and disease is deeply intertwined, as poor sanitation practices can lead to the transmission of various infectious diseases. Here's how sanitation impacts disease. Contamination control. Proper sanitation practices, including the safe disposal of human waste and proper handling of garbage and wastewater, prevent the contamination of water sources and the environment with disease-causing pathogens. Contaminated water and inadequate waste disposal can lead to the spread of waterborne diseases such as cholera, typhoid, and dysentery. Vector control. Sanitation efforts, such as proper waste management and keeping surroundings clean, reduce breeding grounds for disease-carrying vectors like mosquitoes, flies, and rodents. These vectors can transmit diseases like malaria, dengue, and various other infections. Hygiene promotion. Sanitation is closely linked to personal hygiene practices. Access to clean water and proper sanitation facilities encourages individuals to adopt good hygiene practices like hand washing, which is vital in preventing the transmission of diseases, especially those that spread through respiratory droplets and contaminated hands. Improved health facilities. Adequate sanitation facilities, especially in healthcare settings, are essential for infection control and preventing the spread of healthcare-associated infections, HAIs, within hospitals and clinics. Disease outbreak management. During disease outbreaks or emergencies, proper sanitation is critical to containing and managing the spread of the disease. Sanitation measures may include disinfection of contaminated areas, proper disposal of medical waste, and implementation of infection control protocols. Malnutrition and disease. Poor sanitation can exacerbate malnutrition, making individuals more susceptible to infections and diseases due to weakened immune systems. Impact on children's health. Children are particularly vulnerable to diseases related to poor sanitation. Diarrheal diseases caused by contaminated water and inadequate sanitation are a leading cause of child mortality worldwide. Community health. Communities with access to improved sanitation facilities experience better overall health outcomes, reduced disease burden, and improved quality of life. To address the challenges posed by sanitation-related diseases, governments, organizations, and communities must work together to ensure access to safe drinking water, proper sanitation facilities, and education on good hygiene practices. Implementing effective sanitation measures is a fundamental step towards preventing the spread of diseases and fostering healthier and more resilient communities. Alternative arrangements for sewage disposal. Alternative arrangements for sewage disposal refer to innovative and environmentally friendly methods of managing wastewater that deviate from conventional centralized sewer systems. These alternatives are often employed in areas where traditional sewage infrastructure may be challenging or costly to implement. Some notable alternative arrangements include septic systems. Septic systems are individual on-site sewage treatment systems used in rural and suburban areas. They consist of a septic tank where solid waste settles, and a drain field where treated liquid effluent is absorbed into the soil. Septic systems are a decentralized option for wastewater treatment, suitable for properties not connected to municipal sources. Composting toilets. Composting toilets, also known as bio-toilets, are self-contained systems that use composting processes to treat human waste. These toilets employ microorganisms and sometimes earthworms to decompose waste, converting it into nutrient-rich compost that can be safely used as fertilizer. Greywater recycling. Greywater recycling involves treating and reusing wastewater generated from non-toilet sources, such as sinks, showers, and laundry. Treated greywater can be used for landscape irrigation, toilet flushing, and other non-potable purposes, reducing freshwater demand. Constructed wetlands. Constructed wetlands are natural or engineered systems that use aquatic plants, soil, and microorganisms to treat wastewater. As sewage flows through these wetlands, the plants and microorganisms help remove pollutants and promote natural purification. Reed bed systems. Reed bed systems are another form of natural wastewater treatment that utilizes reed plants to purify sewage. The wastewater is filtered through layers of gravel and sand where the reed's root systems provide a habitat for beneficial bacteria that break down contaminants. Biogas plants. Biogas plants combine wastewater treatment with renewable energy generation. In these systems, anaerobic digestion of organic waste, including sewage, produces biogas, a mixture of methane and carbon dioxide, which can be used as a clean energy source. Vacuum sewer systems. Vacuum sewer systems use low-pressure air to transport sewage from individual homes or buildings to a central collection point. These systems are particularly suitable for areas with challenging topography or where conventional gravity-based sewer lines are not feasible. Urine diversion toilets. Urine diversion toilets separate urine from feces, allowing for more efficient nutrient recycling and wastewater management. The collected urine can be used as a fertilizer, reducing the nutrient load in the overall wastewater stream. Each of these alternative arrangements offers unique advantages in terms of cost effectiveness, resource conservation, and adaptability to various geographical and social settings. Implementing these innovative approaches can contribute to more sustainable wastewater management and help reduce the environmental impact of sewage disposal. Sanitation at public places. Sanitation at public places is of utmost importance to ensure the health and well-being of the general public. Proper sanitation practices in public areas help prevent the spread of diseases, maintain cleanliness, and create a positive and welcoming environment for everyone. Here are some key aspects of sanitation at public places. Cleanliness and regular cleaning. Regular cleaning of public places, including streets, parks, markets, and transportation hubs, is essential to remove litter, debris, and waste. Cleaning should be conducted multiple times a day in high-traffic areas to keep the environment tidy and hygienic. Adequate number of trash bins. Providing an adequate number of trash bins at strategic locations encourages people to dispose of waste properly. Clearly labeled bins for different types of waste, such as recyclables and non-recyclables, help promote responsible waste disposal. Waste management. Efficient waste management systems are crucial in public places. Local authorities should ensure timely collection, segregation, and proper disposal or recycling of waste to prevent littering and the accumulation of trash. Public toilets and washrooms. Well-maintained and accessible public toilets and washrooms are essential for the comfort and convenience of the public. Regular cleaning and hygiene checks are necessary to ensure their usability and cleanliness. Hand-washing facilities. Hand-washing facilities with soap and clean water should be available near public toilets and eating areas. Encouraging proper hand hygiene helps prevent the spread of infectious diseases. Pest control. Implementing pest control measures at public places, such as parks and markets, helps minimize the presence of pests like rodents and insects that can spread diseases and create unsanitary conditions. Signage and awareness. Clear signage and informative posters about sanitation practices, waste disposal guidelines, and hand-washing protocols can help raise public awareness and promote responsible behavior. Regular inspection and maintenance. Regular inspections and maintenance of public places are essential to identify sanitation issues promptly. Quick action can prevent deteriorating conditions and potential health hazards. Collaboration with the public. Engaging and involving the public in sanitation efforts can create a sense of ownership and responsibility. Community participation in cleanliness drives and awareness campaigns fosters a collective commitment to maintaining public places. Public awareness and education. Conducting educational programs and campaigns on sanitation and hygiene in schools and public places can improve public understanding of the importance of cleanliness and proper waste disposal. By implementing these measures, local authorities, businesses, and communities can work together to ensure that public places remain clean, hygienic, and inviting for everyone, contributing to overall public health and well-being. Thank you for watching.